Hello and welcome back. This is lesson 6, learning about methods. Now, that doesn't mean we're going to learn how different methods on how to do something, but there is actually some sort of thing in Java or object-oriented programming called methods, which are also called functions. We're going to learn how to build our own custom functions, call them whenever we need, do whatever we want. So, this is how we add function before we add any form. When I say that, what I really mean is like we haven't learned how to do anything with the user interface yet, but before we even use the user interface, we need to learn how to actually add functionality to our programs. So imagine that you had a manual for fixing cars. Now, I love cars. I was a mechanic for a while. Engine theory was like my jam. So you're going to see a lot of car analogies, but that's okay because it's going to I'm going to promise I'm going to dumb it down so at least it makes sense for those of you who are not car savvy. The manual just sits on the shelf for you to use when you need it, and the book has dozens of guides. So imagine that you wanted to learn how to either change your serpentine belt or change the rubber belt on the inside, change your oil, change your air filters. The book is going to have all three of these, and they're going to be printed in an order, but they're not in no particular order, right? If you need to change your oil, you can just open up the manual, go to like chapter 2, and then change your oil. It'll tell you how to change your oil. If you need to change your air filters, you go to chapter 3 and it changes your air filter. It teaches you how to change your air filters. You use whatever chapter you need to whenever you need to. So that's kind of how methods work. We're going to have a class that's going to be laid out in terms of like just a list of methods. And we're going to learn how to call those methods. Oops, I actually have some previous notes on this. We're going to learn how to call those methods whenever we need to, or those functions whenever we need to. So just to kind of give you an idea of what this is really going to look like, here's our class file, right? I'll draw a little tab here so we know that it's a document, right? We have our class, and we have our little curly brackets. Whoop, I always do that. It's because my hand bumps it. Close enough. We have our little curly brackets. That is terrible. All right, we have our little curly brackets. So far, we've actually already seen our first method, but we don't really know what it does yet, right? So we have the main method, right? And we put parentheses to identify that it's a method, and it has a beginning and an end. But that's one function, actually. And it's, in fact, the function that is called by the Java virtual machine. So it calls the main method, we go through the main method, we execute the code inside of it, and then we leave. You can have other functions too. Now, the Java virtual machine isn't going to call those functions, or the Java runtime environment, Java's not going to call those functions, but we can still make them and then call them ourselves. So we can have a function that does something, right? Well, let's say it's called it does something. And then inside here we can call do or does, oh god, something, right? So we always start with the main method because that's what the environment Java is going to call. Let me turn my phone off. There we go. We go line by line. At some line, wherever in the main method, it doesn't matter where, and that's kind of the thing, right? We can call it whenever we need to. We will call do something, jump down to do something, do whatever is inside of this method, and then sometimes we can return something back and then proceed on the main method, right? And the nice thing about this is we can call do something or does something multiple times. And we only have to write it once. We don't have to, like, if there's a loop inside of here, we don't have to, write that loop multiple times. We can just call does something and then we'll jump down to here, it'll execute that loop and go back. It can output some values if we need to also. But that's kind of the point here, is that this is a method, right? And this is a method. They're in no particular order, and Java can just jump to any one of them that it needs to, right? The Java always starts at the main method. It always starts at the main method, but we can go to do something, does something method whenever we need to. Just like the manual in a car. All right. So we don't really know what a class is yet. I mean, we know that it's a file, and so far we just learned that it has a list of methods, or yeah, a list of methods. But for now, just assume a class is a file and contains a bunch of different methods. That's all it's going to do. There's actually a lot more to it, but we haven't gotten there yet. So a class is to the manual as methods is to the instructions. Setting up programs like this allows us to reuse code over and over again in the same program execution without having to rewrite it. And it can make our code a lot easier to read. If you didn't have methods and you had to put all your code in here, that could make it super long to read and make it very tedious. Now, the main method often becomes extremely compact, sometimes only just a few lines. But the rest of the program becomes very big and complex because you will be jumping around. But the main method will have basically like the bullet points to this as do this thing, and then you can look at how that thing happens elsewhere in code. Okay, so here's the basic structure of a method. We need to start with some inputs. We're going to input something. We're going to send values to the method. The method's going to have instructions inside of it. And then we're going to return some sort of value back out of the method back to where the method was called. So we call a method, send it inputs, execute instructions, and then return back to where the method was called. And then proceed on from there. There are 5 parts to the method header. Okay, so these 5 parts are actually just talking about this right here, except for the return type, which I'll get to in a second. So you have the access modifier, static versus non-static, return type, name, and input parameters. So this kind of looks like a mess, but let's start from over here where it says public. This is the access modifier. There are 3 access modifiers. It can be public, lowercase p, by the way, just, the software requires just forces it to be capitalized. It's lowercase p for public, or lowercase public. And if you put public right here, it means that anything and everything has access to call this method. If you put protected, or if you leave it blank, it will be protected. If it's blank, it's protected. If you call it protected, that means that anything inside this package can call this method. Now, a package, which is something we're going to learn again a little later, but a package is like a folder that's full of files, right? It's technically like a zip folder full of files, and all of those files are classes. A group of classes inside of that kind of zip folder is called a package, right? And this could be really useful for, like, let's say you want to have a bunch of classes, like, well, one is like a math class, another one's a science class, another one's a chemistry class, I don't know which is a science class, but you can have all these different types of files that are very related to each other inside a single folder. And that folder, or zip, once it's zipped, will be called a package. So then what you can do is you can distribute your package. Says, hey, if you need to do math and sciencey things, use my package. The last one is private. Private means this and only this object or class can call this method. When we get to objects, this will make more sense. For now, we're stuck in one class. We can't get out of this class. We can't use multiple classes. We can't use objects yet. So in reality, none of this will matter to any of us until we kind of look at using multiple classes. So for us, it won't really matter yet. But for now, you can choose public or private. Don't really need to use protected too often. But yeah. The next keyword here is static. We've seen this one before also in the main method. And for now, I want you to kind of ignore it. You can either write static or leave it blank. For now, if you leave it blank, you will get an error. So all of your methods temporarily have to be static. And the reason is it has something to do with creating instances of objects. So again, that's not going to make any sense to you, but so just make sure that it's static for now. This is the return type. The return type tells us what's going to come out of this method once we completed the method. The next one is the method name. This is how we call it. This is how we identify the method, right? In this example, the name of this method is method example. It could be whatever we need it to be. After the method name, we're going to put a left and right parentheses. And in this case, we have 3 inputs. That's what these 3 things are. These are all inputs. You can have no inputs, 1 input, 2 inputs, 5 inputs, 10 inputs, etc. And they can be integers. They can be either primitive or reference type variables. All you have to do is make sure you define the type. In Java, at least, you have to define the type, the variable name. It's not very meaningful that it's A and B, but that's kind of the point here, just to keep it simple. You have to define it just like any other variable. You don't have to set a value to it. Separate them by commas, and that's it. Define the variable type, the name of the variable, and the name of the variable is local, by the way. Any variables you define here are local to the method. What that means is that they exist in and only inside this method due to its scope, which is something we're going to come back to. We talked about it in the last lesson, and we're going to come back to scope in a little bit. I will define it again. Oh, I should actually back up. The return type double means that we're going to return a double precision floating point value. If you have a return type, right? If you don't want to return anything, you can use void. But if this return type, and you have to have something here. If it's not void, in other words, if you have int, double, string, whatever, you have to have a return statement inside the method. And the return statement has to be reachable. If you have an if statement inside the method, for example, and the first if statement has a return function, but the else does not, then Java will complain. It'll let you know that, return statement is unreachable, potentially. So let's see. All instructions that the method will execute. The curly brackets define the beginning and the end of the method. There isn't anything technically special about the main method. It's structured and functions just like any other method. You could technically call that main method from anything else. But the only thing that's special about it is that it's the one method that the Java virtual machine is going to call, or the Java runtime environment. When you run the program, that's what Java is going to call. This is actually pretty common with most, if not, I think all object-oriented programming. I know I've seen it in C#. I know that C++ uses it. I've never seen it in GDScript when we get there, or Python, but I could be wrong. So yeah, main methods are pretty much a common thing. So let's walk through the program walkthrough example. So I have a program here. Well, I made one off the side, so I'll write one. New project, program example. Create a new class, and then method example. Just like always, delete and delete. So first we're going to start with a main method, so we at least have a starting point for our program. Public static void main string args. And then let's create a function down here called private static. Remember, for now they all have to be static. Int do something. Int d int e. All right, actually, in my program example, I actually should have done this first. Int a equals 5. Int b equals 3. I know the error. I see the error. Don't worry about it. Int c equals do something, not dumb thing. God, I can never type when I record. Do something a, comma b. And then in here, I want to just return d modulus e. Okay, so let's go ahead and walk through this step by step. What I'm going to do is actually, I want to try something actually. Let's see if I can copy this, bring it over here, and then, whoa, that is super duper tiny. Why is it so small? All right, let's see if this will work. This should work, hopefully. Ah, okay, perfect. Can I write on this? No, please let me write on this. Yes. Okay. So the first step, step one, and we're gonna go step by step. Step one, we create a variable called a, and we put the number 5 inside of it. Well, I mean, step one is to create the variable a, and then step two would be like put the number 5 inside of it, right? Because there's kind of like two steps here. So that would be step like 2. So step 3. Hold on, I'm gonna fix my computer here. There we go. Step 3 would be to create the variable b. And then step 4 is to put the number 3 inside of it, right? So we're right here. We just finished this line. Step 5 is to create the variable c. Now, at step 5, we have a problem. We have to call do something, right? Do something right here. So what this line says, jump down to do something, and then put a comma b. And a is 5 and b is 3. So down here, what we're actually going to do is copy the values of 5 and 3. We're not sending the whole variable over. We're making a copy of the variable and sending it. This is called pass by value. So D becomes 5 and E becomes 3. If you modify D and E, nothing will happen to A and B because these are copies of it. Right? So, oh, I spelled return wrong, but that's okay. I'll go back and fix that. The return is D, which is 5, modulus E, which is 3, because the values were passed down here and then over here. So step 5 would be to call do something. And then step 6, well, step 5 is to create C, and then step 6 is to call do something. And then that would be 5 and 3. And then step 7 is put 5 and 3 inside of D and E. D, E, and then 5, and then 3. Step 8. Well, I guess step 7 is to create D and E, sorry. And then step 8 would be to put 5 and 3 inside of that variable. I mean, I'm really going step by damn step. And then step 9 is to return 5 modulus 3, which remember 5 divided by 3 is 1 remainder 2. And the modulus is the remainder, so that just becomes 2. Because 5 divided by 3 is 1 remainder 2. The modulus is the remainder. So we return 2. The value 2 is the return statement. And so that kind of replaces what this whole method call is. We replace do something with 2. So at this line, replace the number 2 here. And then, we have to set it to C. So eventually this will become 2. That would be step 10. So step 10 is to assign 2 into that variable. All right. Okay, that was quite the procedure there. But I want to, here, let me fix return. But notice how I have a method up here and a method down here. I can create more methods underneath it as separate things, just like I have here, right? So there's like public static void main, and then I have the do something method, and then I have another method, and another method, and another method. From somewhere in your program, you must call the method by specifying the name. That's exactly what we did on this line right here. When called, the values get copied and handed the method. Be careful when passing reference type variables. So if we pass by value, what is the value inside a reference type variable? So let's say I have a primitive type variable called a, which has the number 5 in it. And let's say I have a string, let's call it s, and this has a number inside of it, but that string points to somewhere else in memory that says hello. When I call a method and I pass a to it, I make a copy of a. So I make a copy of a, and then it goes to the method, right? Like int a, sorry, this should be 5. I make a copy of the value 5, and then that goes to the method. Now, if I change this, like let's say that this is the variable d, and this is inside the method, right? This whole thing right here is inside the method, and this is from like the main method, and this is from our do something method. If I make any changes to this, nothing really happens. When doing reference type variables, what we do is we make a copy of the reference. This means that when we send it to the function, this is a pointer, and it's actually pointing to the same location in memory. Now with strings, it probably won't happen because strings are immutable, etc. But if I pass something to the reference to an object, and I make a change on this reference variable, in the method, it will actually change it back here. This is the major difference when passing a primitive type and passing a reference type variable. Primitive types won't affect the original, but reference types can. Because in both cases, though, we pass by value, and in the reference type variables, the value is the reference. So that's why we say when we pass like strings or objects later on, this is passed by reference, and primitive types are passed by value. I guess in both cases, you can look at it as passed by value. Just with reference type, they're just the value is the reference, or the pointer that points to the location in memory. So here we have scope again. We talked about this in the last lesson, but scope is where something exists and defines who/what has access to it. For example, the integer b right here only exists inside the main method. If you were to try to call b down here, nothing would happen. It would actually throw an error saying, I don't know what b is. So its scope of access starts when it's created and ends at the right curly brackets of the main method. Thus, you cannot access it from do something. Int d is created in that if statement. So d is created inside this if statement, right? It starts, it's created, it exists where it's created, and after until the next curly bracket, the closing curly bracket, which means I also could not access it inside the do something method, but outside. I can access it inside the if statement, but not outside of it, right? So I can't put like d equals 2 down here and expect it to work. I want to point out something that you've probably noticed, that we have some color schemes going on here in Java. We're actually going to take the time to make 2 changes to our program. The first thing I want you to do is change this. If you like to show this, these colors are the different colors for scope, right? If I make it darker, the yellow says this is the scope of the main method, right? That's what scope highlighting is. That's why BlueJ does this. Other programs won't do this, so it's not necessarily good practice, but if you're not familiar with how scope works, that's fine. Notice that they make it a big rectangle, right? And everything inside of it is accessible. If I were to make a main method, an if statement, if true, true, right? Notice that the true gets its own color. So if I make something inside of here, I can't access it. Int d equals 5. Outside of it, d equals 3. Java complains. So Java allows us to go down in scope, but not up in scope. Very, very important thing to understand. So what if I want a variable, a singular variable, to be accessed by both of these methods at the same time, right? You can actually, I gotta fix this. Okay. You can create something called class variables. You can create something that's outside of all methods as long as it's inside the class. Now remember that this is public class get example. The curly brackets that kind of line up with the class, that's the class's scope. You can create variables directly underneath it. And because it's in a higher scope than both of these methods, or all three of these in this case, all three of these methods have access to it. However, if I had a variable down here, right, we have a variable called, well, not name, but let's say I just had any random variable. I could not set name equal to that other variable because it was created at a lower scope, so I cannot access it from a higher scope. This is an extremely common thing to do. Create a class variable like this, make it private, and use methods to set and return a value back instead of giving direct access to the variable. So whenever you make a class variable, it's most common to create a private method, or I'm sorry, make the variable private. So that keyword public and private that we used on methods can also be used on variables, but only the class variables. You can't make a variable private down here inside the method, because all variables inside of a method are local. That's something to probably note. All variables inside of a class can be modified to have certain levels of access, just like the method. So you'll notice I also put static in front of it. That has something to do with classes. So if you make a class variable, for now, make sure that it's static only. For now. I ask you to make it private, but since we can't really make really complex programs, it won't really matter to us. Now, it's a very common thing to make methods that specifically do one thing each. This method takes a string from, like, let's say a user, and then we'll assign it to this variable. There's also a method called getName. It doesn't take any parameters, but it will return a name. So if I want to return a name back to the main method and then have the main method output it or something, then I want to create the method. So why create methods that do this instead of giving the user direct access to the variable, which you actually can do. If you make this public, you can directly access the variable. I've noticed that it's become more and more common to do that, to let people just directly access variables, but I've always been taught that it's a bad practice. And the reason it's a bad practice is because variables can be accessed by two things at the same time and corrupt the data or cause issues when the two numbers are trying to overwrite each other, essentially. Right? They're both trying to access the same thing at the same time. When we get to multi-threading, this will be more apparent. So what we do instead is we use functions, because functions can be prioritized. You really don't need to know this much about methods, but the real key importance here is to remember that you can create class variables, and that it's common practice to make a variable that simply takes in a variable and sets it to that variable, and then this method will just simply return it. That's all these do. These are called getters and setters because it's set name, get name. So if I make another variable called number of students, I would make another set num or set number of students, and then another one called get number of students. The set number of students will take in a number and assign it to that new variable, and the get number of students will not take anything, but then return and only return that variable's value. So there's one more thing that you probably noticed. Remember how in the last program, everything that we made here inside of this was a brand new variable, right? Because it looks like a variable declaration, string name. The problem is the class also has a variable called string name. And this string name is accessible by the variable called set, or I'm sorry, the method called set name, because it was created at a higher scope, therefore we have access to it from a lower scope. So how do we have two variables that exist in the same scope with the same name? This seems very counterintuitive or very confusing. The way that we define each one, if you use the name, if you use a variable name, it always defaults to the more local of the variables. So right here, this is actually referring to this one, this copy of it. If I want to refer to the one from the higher scope, in other words, at the class level, all I have to do is put the class name dot name. What this tells Java, it says go to the get set example program, the class, which is all the way up here. It says go all the way up to the top, and then go down into it and look for a variable called name. You can also call functions like this too. You can do get set example dot get name left and right parentheses, and that'll work. I mean, that's kind of dumb here. It wouldn't work here. You would have to get rid of the equals name, but you can call functions like that as well. I don't want to get too far into like how to use this because you're going to get practice with it. You don't always have to use get set example before. You don't have to call the class and then the name. You don't have to call the class and then the variable and every example, but you do in this case because you have two variables of the same one. This is how we distinguish them. That's the only thing I really need you to understand. And again, you can use get name. You can do get set example dot get name. Just copy this and do dot get name. The only time you don't need to do, so you wouldn't have to do that because it's weird, but functions have access to call each other too. But you don't have to because as long as if it's a function that's in this class, you don't need to do that with functions, but you can. The only time you need to call the class and then call the name of the function is if it's in another class. Sorry, I know I kind of went in circles on that one, but I hope that made sense. I kind of want to say it one more time. If you have two variables of the same name, the class one has to be, you have to call the class and then the variable name if you want this one. This one doesn't require it, it'll call the local one. For functions, you can also do the class name dot the function name. But if that function is in the same class, you do not have to do that. There you go. That's a much simpler way of saying it. Overloaded methods. It's perfectly fine to have two methods with the exact same name exist in the same class, as long as they don't have the same signature. So what the heck is the signature? In our example, oh, I forgot to do that second thing, but that's okay. In our example, the do something signature is the name of the function plus its input parameters. So everything I highlighted here is the signature. I can create another method, private static int do something, and then I can have it do int f, int d, int e. And Java is not going to complain. Oh, I do have to return something. Return f plus d plus e. There you go. So Java is not going to complain. So how do I call one do something method as opposed to the other one? Well, all I have to do is down here, I can call, let's int d. Yeah, okay, I wasn't sure if that would make an, no, that should be fine. Int d equals do something. All I have to do is feed it 3 parameters, right? So I can do A, B, C, and that's it. Now, the reason this works is because A is an integer, and the second method requires that the first one be an integer. B is an integer, and the second one requires D to be an integer. C is also an integer, and the third parameter has to be an integer. Integer, 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 integer. That's the real big key difference here. Same name, and as long as it matches the same input parameters as down here, as one of these methods, it'll work. It knows which one to go to. So if C was a double, then this would break. It would say, I don't have a method called do something that takes in an integer, integer, and then a double. So this is called method overloading. Let's take a look at the math class that's online. So if I go to Java, if I type in Java math class, right? Java has a document for every single class that's built into Java, right? Obviously, it's not going to have classes that are built from other people, but the ones that are built by Oracle, the ones that are just inherently usable, are here on their website. First of all, remember how we made the variables at the top of the class? Let's make one. Int class variable 1. Now you can assign it a value. And that's perfectly fine. You don't do any arithmetic up here, right? So don't try to call, you know, class variable 1 equals do something 3, 5, right? Let's see what the exact error is. Identifier expected. Because Java only wants you to declare variables, not do arithmetic or call functions to try to return something back to it. So the most common thing to do is to just have it be blank. When we get to classes and calling something called constructors, we'll show you that there's a common way to initialize it. So in the main method, we always immediately put a value inside of it to initialize it. When we get to constructors, that's where we're going to do it originally, but we haven't gotten there yet. So for now, just make class variables that are just completely blank. And Java's not going to complain about it, so that's fine. So let's look at the math class. There are two class variables, e, which is Euler's number, and pi. It doesn't say final, but I'm pretty sure that these are both final. Oh yeah, it is final. Okay, so public static final double e. The double value that is closer than any other to e, Euler's number, the base of the natural logarithm. Who cares? It doesn't matter to us. However, inside the math class, method summary. This is the list of all the methods that exist inside of the math class. You never really need to know or memorize any of them. You could always Google Java and then, like exponent function, and then it'll probably take you to this, this right here, the exponential. So let's look down here and notice that there's 1, 2, 3, 4 methods called max, but each one takes different inputs. The first one takes doubles and returns a double. The first one takes 2 floats and returns a float. Specifically, the definition is returns the greater of the 2 floats. So if A is like 1.0 and B is 1.1, it's going to return B. That's all that this function does. But there's 4 of them: longs, ints, floats, and doubles. This is function or method overloading. Okay, let's make a program called Palindrome. So in BlueJ, let's delete this. Okay, remove. Let's create a new class called Palindrome. Oops, I didn't want to open that. Sorry, that's metadata. That's how you can like modify information about the thing. Don't worry about it. Function, and then I want to put this over here. do our normal thing. And public static void main string args. All right, a palindrome is a word that is spelled the same backwards as it is forwards. For example, race car backwards is race car. Make a program that has a single method that takes a string, checks if it's a palindrome, and returns true or false. Here are 3 functions that are actually specific to strings. So if you Google Java string functions, these 3 are in there. I just went into the documentation myself and then pulled these 3 out and are giving them to you as like a hint. So this will be a lot easier to create. So inside of here, let's make first we want to make we want to take an input from a user, right? So we do scanner in equals new scanner system.in. Now we also need to import that statement. Import java.util.scanner. We don't know what importing is yet, I know, but it's okay. Slowly but surely we are learning more and more about programming. This is going to all come together very soon. String pal check, right? This is going to be a string that holds that we're going to use to check if it's a palindrome. In.next. And let's do a loop while pal check dot equals exit Okay, so this statement says if the basically check to see if the user types in the word exit, right? So if they type in the word exit, this statement will be true. But remember that while loops execute when the input is true. So I negate that by a not. So if it's not true, keep doing this loop. So if they type in exit, this pal check.equals becomes true, but the not makes it false. And once it's false, it leaves. This is how we can say if they type in exit, stop the loop. Okay, so we need a way to check. We're going to call a function called isPalindrome, have it check to see if it's a palindrome, return true or false, and then print it out, right? So I'm going to need a variable called Boolean isPalindrome equals false, just to start off. And then palcheck. Oh, I already got palcheck. Palcheck, the user inputs a string and in.next. So then I got to do isPalindrome equals. Let's make the function first. I want it to be public or private, it doesn't matter. I'm going to make it public for now. Oh, it's got to be outside the main method. Public static. Remember, all of our methods for now have to be static. And we want it to return a Boolean that's like yes or no as to whether or not it is a palindrome. So I need Boolean. I can't call it isPalindrome. Palindrome check. And it takes in a string. A or test string. Okay, so we have to return something. So just to make sure that Java stops complaining, I'm just going to return false for now. Right, so what do we have to do? What's one way that we can actually check to make sure that race car is a palindrome? Well, all we have to do is check the first and last. If they equal each other, move on to the next one. Check the second and the second to last, and then the third, and then third to last, and then the last. And you can either keep going all the way until you reach the ends, or you can do a little bit of extra work to make sure that it's like if you're on the same index or if the first index is greater than the second index, then just exit. But That's a little bit much more programming. If you want to make your program more efficient, I encourage you to give it a shot to do that. But we're just going to go all the way from one to the other side, right? So we're going to check the first to last, second to last, third and third to last, the middle, and then like we're gonna check these two again, and then again and again. It won't matter though. So let's just do that. Let's see. We want to do a loop for int I equals 0, I less than test string dot length minus 1 I plus plus. So first, you might be wondering why I'm using a for loop. You can use a while loop too, just remember that you have to kind of control it a bit more. When I was talking about the race car, I said we want to check the first and last number, the first index and last index. This told my brain that I'm going to be using indexes. So if I'm going to be using indexes, then I'm probably going to want a for loop. The while loops don't require indexes, and neither do while loops. You just have some sort of condition. In this case, if the user types an exit, the user types an exit has nothing to do with indexes or indexing. Sorry, this is a function. Okay. So we want to compare is is palindrome is going to be equal to test string dot char at I that's right. Okay. If test string at char, that's what I was doing. Ugh. If the first character, right, because I is equal to 0 on the first iteration, if the first character is equal to the last character, length minus 1. I don't like doing that here. I'm going to get rid of the spacing on this and make it a little bit easier. Oh, right. Test string dot char dot length. Right, because we have to say you have to do the string's length. You have to do string dot length because you need to call the string's length. If this is confusing, it's because we haven't learned how to call functions on specific variables yet. Only functions within classes and functions of whatever. Just type this out for now. This will make sense later on. So this will actually give us the length of the string. The problem is race car is 5 characters long. I'm sorry, 7 characters long. 1, 2, 3, 4, 5, 6, 7. So if I check this character at index 7, that's actually out of bounds because remember the first character is index 0, 1, 2, 3, 4, 5, and then 6. So index 7 is out of bounds. You're going to get an index out of bounds exception. That's why I'm subtracting 1 from it. All right. So then testing that char at length minus 1, so in other words 6 in this case, if that's equal to the character at index 0, do nothing. Let's just do nothing. Otherwise, if they're not equal, that's when we want to return false. Because as soon as the first and last character, or like the second and second last character, as soon as our two characters don't match, it's not a palindrome. So we can return false and just stop. Because returning false will definitely work. So we have a return statement. Great. Can we get rid of this? No. Look at this, missing return statement. But I have a return statement. The reason it's saying missing return statement is there's no guarantee that this else statement will ever happen. And we have to return a Boolean because that's what this method demands. So what it means is that we have to return something. So what do we want to return? Well, if we go through the entire string and we never get a false, then the loop will end. That means that it has to be a palindrome. So we'll have to return true. So let me say that again. If we ever go through the string and we get a mismatch from checking the first and last, second to last, and if we ever get two characters that don't match, then it is not a palindrome. So we will just return false, and the return statement will terminate the for loop, by the way, because we're leaving. That's what return means. It means to leave. If we never hit that else statement, then we never have a mismatch in characters, and therefore the for loop will eventually end, and then we have to return true, or we want to return true. So let's give this a shot. Actually, we're not done. So we made our palindrome. This is how we check if it's a palindrome. Now we actually have to check it. Is palindrome equals palindrome check, and then we're going to pass the string to it, pal check. So why did I make a while loop? This is so that we can run this program over and over and over again until we hit the exit button, or we type in exit. You don't actually need to make a while loop, but if you don't make a while loop, you can only run this program once and check one string. This will let us check any string except for the word exit. Why did I capitalize that? System.out.print line is palindrome, and then pal check equals in dot next. All right, so first we're gonna just initially ask the user for an input. If that word is an exit, then go in here and send it to the palindrome method down here. The palindrome method will run, right, going index by index, checking the characters. If it is or isn't, it returns a Boolean. So this statement right here will eventually turn into a true or a false and get assigned to the variable called isPalindrome. Then we're going to print it to the terminal and then ask the user for another input. Now there's no textual prompt that says please give me another input. You can do that, but I'm not doing that here. I'm just going to keep asking for it. Let's see if this works. Race car. All right, so it says false. Well, we know that that's actually a palindrome, so let's see what we did wrong here. Oh, I can type in exit, and then when you type in exit, you'll notice that this no longer allows inputs, and this blue bar disappears. That's the way that we kind of, when the blue bar is oscillating, it says that the program is still running. This button will force it to quit. Anyways, let's see what happened. Teststring.char at I. Let's say that was 0, right? Which it is on the first one. Teststring.char at teststring.length, which is 6, right? Well, it's 7 minus 1, which is index 6. If the test strings, if the 0th and 6th index are equal, do nothing. Otherwise, return false. You know, we could also rewrite this as saying, if the first one does not equal the second one, return false. And this actually should make it a little bit simpler. So let's say index I++, right? We check the first and last one. I++. Ooh, that's what it is. I need to subtract I, not 1. I minus 1. So I need to do both. So why? Because if I want to check the 6th one, and let's say that length is 7, because length is 7, I is 0, well, length minus 0, that's going to be 7. That's going to be out of bounds. So we need to subtract 1. But now let's say that I is 1, right? String length is 7 minus 1 minus 1. That allows us to go back 2. And then on the next one, I will be 2, and that allows us to go back 3, and so on and so forth. Now let's see if our fix worked. True. And then bab, rab should be false. All right, cool. This seems to be working. And then I can type exit to force it to quit, or you can hit this button down here. And that should be it. So there's a lot to go over. If you want to take some screenshots of what I kind of posted over here, let's kind of just do a very quick review. Methods are functions, right? They're groups of code that we can call over and over and over again. And this is so going to grow into so much more later on. But classes are going to have lists of functions or methods. Each method is going to have its own thing. Methods can call each other. They can call even themselves. That's called recursion, but we'll get to recursion later. Do not do recursive functions yet. You can create class variables. You may want to kind of look into that a little bit more, but class variables help us give one variable or a common group of variables that are accessible by every function. Don't forget your accessor, static for now, your return type. If no return type, make it void. You need to give it a name and some set of input parameters. If you want to overload the function, you need to change the input parameters in some way. This is really useful if you want like the max. What if you want to do the max of 2 numbers, but you have a long or an int or string, just like in the math class? That's one way that we overload methods. What else? Getters and setters. All getters and setters there's nothing special about them. It's just a common practice. Is a function that sets and gets and return either sets the value of a class variable or returns the value of a class variable. When I first learned about getters and setters, I thought they were some special thing, but they're really not. And that's like this is the kind of stuff that I'm really glad to hopefully teach you guys. It's like there's nothing special, but people are like getters and setters, and I'm like, oh, they must be special types of methods. They're not. It's just a common practice that is used in programming. Remember your scope. Don't accidentally create a variable in a lower scope and try to access it from a higher scope or from another scope, right? And don't forget that you can create integers or values of integers. Oh my God. You can create variables of the same name in different scopes. We're going to actually talk about this too. I feel like I overdid it, the explanation on this, but that's okay. If you didn't get this, like get set example.name versus name using this one, don't worry about it. We'll come back to it when we talk about class names, class variables, classes, and instance objects, etc. Okay, that should be it. If you guys have any questions, please leave a comment. I know that these are starting to get much more complex. So if there any feedback you guys can have, hopefully constructive and not just like, oh, you're a douche, uh, let me know, and I'm more than happy to remake these videos. They are pretty long and pretty exhausting, but I will definitely make them so that they're good. I'm getting excited, so let's see what's in the next one, and I'll see you guys there.